The search for extraterrestrial life. Hey guys, welcome to Space Explorer channel. The extraterrestrial life in the universe has been an enigma for generations. For centuries, people have speculated about the possibility of extraterrestrial life and whether it exists beyond our planet. With the recent advances in technology, our understanding of the universe has grown significantly, and scientists have been able to search for evidence of life on other planets. In this video, we will discuss the latest discoveries and theories about the potential for extraterrestrial life in the universe. Before moving forward, if you are new to our channel, don't forget to like and subscribe our channel for future interesting videos. The search for extraterrestrial life. For centuries, humans have looked up at the stars and wondered if there could be life out there. With the advancement of technology and scientific research, the search for extraterrestrial life has become a legitimate pursuit of scientists and astronomers around the world. The search for extraterrestrial life begins with the belief that life exists beyond our planet. Many scientists and astronomers believe that there is a high probability of life in our galaxy alone. In fact, recent discoveries of habitable environments in our own solar system have raised hopes of finding extraterrestrial life in our own backyard. One such possibility is on the moons of Jupiter and Saturn, where there are subsurface oceans of liquid water. These oceans are kept warm by tidal forces from the gas giants, which could provide the necessary energy for life to exist. Additionally, the discovery of water on Mars and evidence of a wet and warm past have fueled excitement about the possibility of finding microbial life on the red planet. Another method for finding extraterrestrial life is through the search for exoplanets. An exoplanet is a planet that orbits a star outside our solar system. Astronomers are looking for planets that are within the habitable zone, which is the distance from a star where conditions could support life. The search for exoplanets has yielded numerous discoveries, including Earth-sized planets in habitable zones of nearby stars. Despite the many possibilities and recent discoveries, the search for extraterrestrial life still faces many challenges. The vastness of space makes it difficult to search for signs of life on other planets, and the technologies needed to detect life may not yet exist. Additionally, the distance between Earth and potential extraterrestrial life forms may be so great that communication is impossible. Nonetheless, scientists continue their pursuit of extraterrestrial life through projects like the SETI, Search for Extraterrestrial Intelligence Institute. SETI searches for signals from intelligent life beyond our planet by monitoring radio waves and other forms of communication. While we may never know for sure if there is extraterrestrial life out there, the pursuit of finding it is a testament to the curiosity and innovation of the human spirit. The search for extraterrestrial life continues to inspire and motivate scientists and the general public alike. Possibility of life in our solar system. The search for extraterrestrial life doesn't always require us to look beyond our solar system. In fact, some of the most promising places to find evidence of life are within our own celestial neighborhood. One of the most intriguing targets for the search for life is Jupiter's icy moon, Europa. This moon has a subsurface ocean of liquid water that may be kept warm by tidal heating from its gravitational interactions with Jupiter and other moons. Scientists believe that this subsurface ocean may contain more than twice the volume of Earth's oceans. In 2018, NASA announced plans to send a mission to Europa in the 2020s to explore its potential habitability. Another target in our solar system is Saturn's moon, Enceladus. This small icy moon has a subsurface ocean, similar to Europa, but also has geysers of water vapor and ice erupting from its south pole. This plume has been sampled by the Cassini spacecraft, revealing that the ocean may contain organic compounds and possibly even microbes. Future missions to Enceladus are being considered to study this fascinating moon in more detail. Closer to home, Mars has long been considered a possible site for past or present life. While there is currently no evidence of living organisms on Mars, there are signs that liquid water may exist below the surface. NASA's upcoming Mars 2020 rover mission will search for signs of past microbial life on the red planet. Even the dwarf planet, Ceres, located in the asteroid belt between Mars and Jupiter, has shown potential for the existence of liquid water below its surface. Data from the Dawn spacecraft has revealed bright spots on the surface that may be caused by salt deposits left behind from water seeping through the crust. The potential for finding life within our own solar system is a promising and exciting prospect for scientists and the general public alike. Exoplanets and habitable zones. With advancements in technology, scientists have discovered thousands of exoplanets, planets that orbit stars other than our Sun. The discovery of exoplanets has given us hope that there could be other habitable planets like Earth out there. But what exactly makes a planet habitable? A planet's habitability depends on a number of factors, such as the distance from its star and the composition of its atmosphere. This leads us to the concept of a habitable zone, also known as the Goldilocks zone. This is the range of distances from a star where a planet's surface temperature is just right to support liquid water, a key ingredient for life as we know it. The habitable zone is not a guarantee of life, as many other factors come into play. A planet must also have the right atmospheric composition and a stable climate. For example, Venus is within the habitable zone of our solar system, but its thick carbon dioxide atmosphere and scorching temperatures make it inhospitable for life as we know it. On the other hand, Mars, although outside the habitable zone, has conditions that could potentially support life if there is liquid water beneath its surface. In recent years, several exoplanets have been discovered within their star's habitable zone, including Proxima Centauri b, Kepler 186f, and TRAPPIST-1, among others. While the possibility of these planets supporting life remains unknown, they have sparked excitement among scientists and the public alike. Despite these discoveries, finding life on another planet is a daunting task. Even if we were to discover a habitable exoplanet, we would need to send probes to analyze its atmosphere and look for signs of life. Additionally, the vast distances involved in interstellar travel would make any search for extraterrestrial life extremely challenging. Nevertheless, the discovery of exoplanets and the search for habitable worlds are driving us closer to answering one of humanity's most intriguing questions. Are we alone in the universe? Challenges to finding extraterrestrial life. While the search for extraterrestrial life is exciting, there are a number of challenges to finding it. The vast size of the universe, coupled with the limitations of current technology and our understanding of biology, makes the task a daunting one. One of the primary challenges is simply the vast distances between stars and planets. The nearest star to our Sun, Proxima Centauri, is over 4 light-years away. This means that even if there were life on a planet orbiting Proxima Centauri, it would take over 4 years for any signals or spacecraft to reach us. Similarly, the nearest potentially habitable exoplanet is over 12 light-years away, making it extremely difficult to investigate. Another challenge is that we still do not fully understand the conditions necessary for life to exist. While we know that water is a key component, there may be other factors that we are unaware of. Additionally, we have yet to observe life forms that exist in extreme environments, which means we may be overlooking potential habitats for extraterrestrial life. Technological limitations are another significant hurdle. Our current telescopes and sensors are only capable of detecting planets and stars within a limited range of distances, making it difficult to search for extraterrestrial life beyond these ranges. Additionally, the search for signals from other civilizations is hampered by background noise from natural sources, such as pulsars and quasars. Finally, there is the possibility that extraterrestrial life exists, but we simply have not detected it yet. This could be due to a number of reasons, including our limited technology or the fact that we have not yet looked in the right places. Despite these challenges, scientists remain optimistic about the search for extraterrestrial life. With advances in technology and our understanding of biology, it is possible that we may soon find evidence of life beyond our own planet. The Drake equation. When it comes to the search for extraterrestrial life, there are a lot of variables to consider. How many planets are out there? How many of those planets could potentially support life? How likely is it that intelligent life would emerge on those planets? The Drake equation is a formula that attempts to take all of these factors into account in order to estimate the likelihood of finding intelligent life elsewhere in the universe. The The equation was developed by astronomer Frank Drake in the 1960s. It takes the following factors into account. R*, the rate of star formation in our galaxy. Fp, the fraction of stars that have planets. Ni, the number of planets per star that are in the habitable zone. Fol, the fraction of habitable zone planets that actually develop life. Phi, the fraction of planets with life that develop intelligent civilizations. Fc, the fraction of civilizations that develop the technology for interstellar communication. L, the length of time that these civilizations remain detectable. By multiplying all of these factors together, you can estimate the number of intelligent civilizations in our galaxy that we might be able to detect. Of course, there are a lot of uncertainties and assumptions built into the Drake equation. We don't know for sure how many planets are out there, or how many of them are in habitable zones. We don't know how likely it is for life to develop, or for civilizations to arise. And we certainly don't know how long these civilizations might last before they go extinct. Despite these uncertainties, the Drake equation is still a useful tool for thinking about the search for extraterrestrial life. By breaking down the problem into smaller, more manageable pieces, we can begin to understand the various factors that might be at play. And by working to reduce these uncertainties, we can get a more accurate estimate of how likely it is that we will find intelligent life elsewhere in the universe. SETI, searching for signals. The search for extraterrestrial intelligence, SETI, has been ongoing for decades, with the aim of detecting signals from potential alien civilizations. SETI searches for patterns in radio and light signals that could indicate the presence of intelligent life. The most famous SETI project is the SETI Institute, which was founded in 1984. The Institute operates a number of telescopes, including the Allen Telescope Array in California, which searches for radio signals in the hope of detecting evidence of extraterrestrial intelligence. Other SETI projects include Breakthrough Listen, which uses radio telescopes to listen for signals from nearby stars, and the Messaging Extraterrestrial Intelligence METI project, which sends messages to potential alien civilizations. The SETI search has not yet found any definitive evidence of extraterrestrial life. However, it has provided valuable data on the number of potential targets for SETI, as well as the technological capabilities of the search methods. One of the main challenges facing SETI is the vast distances involved in interstellar communication. Signals from even the nearest stars would take years to reach us, making real-time communication impossible. The signals we receive could be outdated by centuries or even millennia, rendering them of little practical use. Another challenge is the difficulty in distinguishing natural phenomena from artificial signals. Radio signals can be produced by a variety of sources, from stars to quasars. It is essential for SETI to be able to differentiate between natural and artificial signals, which requires a detailed understanding of the underlying physics. Despite these challenges, SETI continues to be a vibrant field of research. Advances in technology are enabling us to search for extraterrestrial life in new ways, and the continued exploration of our solar system is also revealing new potential targets. Whether we find evidence of extraterrestrial intelligence or not, the search itself is an important exploration of our place in the universe and our understanding of what it means to be alive. The Fermi Paradox. As we continue to search for extraterrestrial life, we must also grapple with the perplexing Fermi Paradox, which questions the apparent contradiction between the high probability of the existence of extraterrestrial civilizations and the lack of evidence for their existence. Named after physicist Enrico Fermi, who famously asked, "Where is everybody?" During a conversation about the possibility of extraterrestrial life, the Fermi Paradox asks why, despite the vastness of the universe and the abundance of potentially habitable planets, we have yet to make contact with an extraterrestrial civilization. There are several possible explanations for the Fermi Paradox, including the possibility that we are alone in the universe, that extraterrestrial civilizations are too far away or too different to communicate with, or that they are deliberately avoiding us. Some researchers have even speculated that extraterrestrial civilizations may have already come and gone, leaving no trace of their existence behind. Another explanation is that we simply have not been searching for long enough, or with advanced enough technology, to detect signs of extraterrestrial life. As we continue to develop more advanced telescopes and space probes, our chances of finding evidence for extraterrestrial life may increase. Despite the many possible explanations for the Fermi paradox, it remains a thought-provoking and fascinating mystery. As we continue to search for extraterrestrial life, we must also grapple with the paradox and its implications for our understanding of the universe and our place within it. Whether or not we ever make contact with an extraterrestrial civilization, the search for extraterrestrial life will continue to inspire awe, wonder, and curiosity for generations to come. Concluding thoughts on the search for extraterrestrial life. As we conclude this discussion on extraterrestrial life, it's worth emphasizing that the search for life beyond our planet remains one of the most fascinating endeavors of modern science. The universe is vast, and we have barely scratched the surface of its possibilities. While we have yet to discover definitive evidence of life beyond Earth, we continue to make remarkable strides in our understanding of how life might evolve elsewhere. From our own solar system to distant exoplanets, we're continually finding new and exciting ways to explore the potential for extraterrestrial life. Despite the progress we've made, there remain significant challenges to our search. Our current technology may limit our ability to detect life beyond Earth, and our assumptions about the nature of life may prove to be too narrow. At the same time, the sheer size of the universe and the possibility of countless other civilizations leave open the potential for incredible discoveries in the future. Ultimately, the search for extraterrestrial life is an exciting and rewarding journey that continues to captivate the imagination of scientists and the general public alike. Whether we ultimately discover intelligent alien civilizations or simply microbial life on other planets, the implications of these findings would be truly monumental for our understanding of the universe and our place within it. As we continue to push the boundaries of what we know, let us remain ever curious, ever open-minded, and ever eager to explore the possibilities that await us among the stars. In 1997, it was estimated that there are about 60 galaxies in the Bouvier void. To give you a better idea of the magnitude of the supervoid if our galaxy, the Milky Way, was at the center of the void, we would not have known that there were other galaxies until the 1960s. The theory favored by scientists to explain this void is that it was formed from other voids of smaller dimensions, in the same way that soap bubbles come together to form a single soap bubble of larger size. This is the phenomenon of coalescence. Another theory had been put forward, according to which the vacuum was simply an area of the universe that had been cleaned by gravitational forces. But not enough billions of years have passed for this to have happened. But other astronomers are not convinced by this explanation. After all, these large voids are not very common in space, so why wouldn't the explanation be artificial? When you look at the night sky, you can see that the universe is composed of billions of stars grouped in galaxies, which form clusters of galaxies. Each galaxy cluster is relatively close to its neighbor. The vacuum therefore exists in space, but not on such large areas. A theory has emerged involving the presence of extraterrestrials. The supervoid would have been formed by the expansion of a Type 3 civilization on the Kardashev scale. Such a civilization would be able to collect and consume all the power emitted by its galaxy. It would have been able to build a gigantic Dyson sphere which would have occulted all the stars and galaxies present in the void. This hypothesis could explain the spherical shape of the void of the Cattleman. You wonder if extraterrestrial life would have had time to develop so much. Technologically, the answer is yes. The Bouvier void is located 700 million light-years from Earth. What we observe is what it was 700 million years ago. Astronomers estimate that intelligent life could have appeared in the universe 4 billion years ago. A civilization that appeared 4 billion years ago would have had 3.3 billion years to develop and build such a structure, but for the moment, no evidence has been found to confirm such a hypothesis. Our journey is coming to an end. During this journey, you will have discovered strange objects that suggest that life is not limited to our little planet. These discoveries are very exciting for the scientific community, but don't forget that on the scale of the universe, a civilization lasts the time of a blink of an eye, even if we are lucky enough to spot an extraterrestrial civilization. One day it will certainly have existed and disappeared several million years ago. Thanks for watching.